So yeah, today I will talk about like what we did 2 years ago, me and my co-founder Claudia, and yeah, like what we learned because let's be honest, it was a hard journey and we learned a lot during this. Like we learned a lot about bug bounty and a lot. We had to solve a lot technical challenges. To start, yeah, I am co-founder of Vidoc Security Lab. I'm a climber and coffee lover as well. Like these are my two things that are almost the most important things in my life. But yeah, I play CTFs, like not so often today. But yeah, like when I find time, I would love to play some more. So I will tell you about story. That like we were able to find issues in 1 year and we earned around $120,000 from that. We were able to find issues in like all of these companies that you can see on the slides. Yeah, like all of these companies paid us money. To like show you the scale of our bug bounty, like it was a huge thing for us because we wanted to scan all of our all of the public bug bounty programs from like different platforms. There are like so many bug bounty platforms right now that you know probably about HackerOne, Background Integrity, and like Hack and Proof and other, but there is so much more. And in general, we were scanning around 3,000 root domains daily, which like resulted in finding 2 million unique web servers. And we were sending around like more than 100 million HTTP requests daily. So yeah, this was huge scale for us. And yeah, like, and we were finding around or like more than 200 security issues weekly. Our initial goal with the automation was we wanted to automate our bug bounty and we wanted to do it cheaply because yeah, like the scale of what we wanted to do was huge, and we were like we knew that it would cost us a lot of money. So yeah, like we wanted to do it as cheaply as we could. Our first try was or our initial idea was let's just take all of the open source that you're probably using in your bug bounty and let's like slap it together and yeah, put it on Kubernetes on Google Cloud and yeah, let's automate with that. But yeah, I will ask you like what tools do you use in your bug bounty, because probably these tools that we used you are also using yourself. I created a pool. You can answer questions. Yeah, maybe we'll look at the results later. I will hide the pool. Yeah, and our first try with creating the automation wasn't so great. Like we felt miserable because it turns out the nuclei and AMAs and Nmap were like turbo slow. We were like running all of the workers like because we had around 20 to 30 workers running all the time, and it was really expensive because yeah, we're paying like for every minute of the machines, and the machines were running 24/7. So yeah, it was expensive. And one more thing that we didn't expect was like the issues with the database, because the results from the tools that we used, we wanted to save them in the database for like and we wanted to have like really nice search experience on that. And yeah, like our database was dying all the time, and like yeah, we had to manage it. And we basically wanted to hack, but we had to think about how to manage the infrastructure. And also another thing that we didn't expect was the cost of Google Cloud, or like cost of networking in general in clouds. As I mentioned before, like we were sending like millions HTTP requests daily, and all of the requests were like costing us money on Google Cloud because you pay for all of the traffic that is exceeding the Google Cloud, and if it is exceeding like to the exceeding to the internet, you will have to like pay a lot of money for it. So yeah, next iteration, like basically we like thought about it, like yeah, it didn't work so well. Let's make something better. So we basically created the goals that we wanted to achieve in the next iteration of the automation. We wanted better speed and accuracy because, as I mentioned before, all of the tools that we used before, like yeah, they didn't scale very well and they were slow or like not fast enough for us. And one thing that didn't work as well was port scanning. We were scanning all of the ports, all of the hosts, and yeah, like it didn't work. It took too much time, so we changed that to scanning only 3,000 of the most popular hosts ports. And also, yeah, like we wanted to decrease the cost because let me tell you, like it was really expensive. Our next iteration of the scanning automation of our bug bounty automation was we left the AIM asset subfinder, but we had spent a lot of time on changing the configuration, like learning how to make it faster. We replaced the Nmap with MassScan. MassScan is basically also a port scanner, but it is a lot faster. There was like still a lot of things that we had to learn about MassScan. It has like basically MassScan you can trade speed and accuracy. So you had to like choose wisely which one you wanted. And we also like ditched the nuclei. Like it was too slow for us, and we built a custom scanning engine from like ground up, and it was like designed for us for a big scale. We still use the Kubernetes because it was great, and we ditched the Google Cloud. We switched to the DigitalOcean because DigitalOcean has free networking for each machine that you use. They give like 1 terabyte or like 2 terabytes for every machine that you use. So, and also the networking is shared between machines. So this was like great for our use case. Another improvement was that we made the machines scale to 0. So in the previous iteration, we always had like 20 or 30 machines running all the time. And in this iteration, we wanted it to scale down to 0. So the machines will only work when there is like a work to be done and when we wanted to scan, but they will be disabled when there is like nothing to scan. And another thing is we had like IP rotation because if you had the same IPs for like a couple of days of scanning, you will get blocked by all of the WAFs, Cloudflare, and like other companies. So basically, yeah, we had IP rotations on our nodes, and we use different databases. We tried so many different databases. Like at the beginning, we started with I think it was Firebase. It was bad choice. We used some SQL databases and like different stuff, but we ended up with NoSQL database with Cassandra to be exact. Our custom scanning engine. We thought about it a lot, and yeah, like we wanted to build something that will be optimized for big scale. Basically, we took everything good from the nuclei because nuclei like they did many things good, and we wanted to improve on that basically. But we wanted to add our own features and make it like faster. So as you can see, like we had really similar YAML format to like be somewhat compatible with them. But we added our own things. One of the features that we added was you were able to define in the YAML how often you want to scan for this vulnerability, and you could define like on what host you would like to run it. So basically, we had this like huge database of recon data, and in the module you could specify that like the trigger, as you can see there, you can define a query that that would match some host, and this module would execute only on this host. So you could create like a query that would match only specific technology, like Nginx or like something different. So yeah, it was great. And also you could like specify that the module can run like every day, every hour, like as you wish. And also you could specify like what would happen if you match, like if we find something. You could report you could report a vulnerability, or you could add a tag to the target. So yeah, it was like different things, but sometimes you wanted to like mark a target and like add some new technology or like something different. Yeah. Another feature that we added to our custom scanning engine was global matchers. Basically, it was like a grep, but for all responses. So the module with global matcher didn't send any requests, but it tried matching the patterns on all of the responses received by from like different modules. So if you had like 10 modules that were running and like sending different requests, like they were working like nuclei templates, you can think of them. So the global matcher basically like grabbed on all of these responses, and it was a great improvement, like great feature, because it allowed us to find like issues that weren't found by other people, because there were so many edge cases that, for example, it was great for bucket takeovers, because sometimes the AWS bucket takeover can be like on different path, or like there's so many edge cases, or like database error, or like stack traces in responses. They could be like on any path, and if some module by accident like finds it, this global matcher will detect it. So yeah, it was great. Our scanning approach, we didn't use all of the like nuclei templates. We had different approach. We basically in 1 year we created around 70 modules, or like 71 modules, or like we created our own modules, or we edited existing modules. And we wanted to make sure that our modules are custom. Like we added a lot of like new paths and like our own ideas to those modules, because if you want to find something, yeah, it's really hard. It's really hard to find issues with the same templates that everybody else is using. So yeah, we basically we used less modules, and like we spent more time on making sure that they are good. Also, we collaborated with other people. Yeah, after we created a blog post, many people reached out to us with some 0 days and like other issues, and we helped them find those issues in many bug bounty programs. And one thing was we scanned for the same vulnerabilities, the same bugs over and over again, because if you scan company today, and if you don't find anything, it doesn't mean that the company is secure, because developers constantly develop new features and like they change code. And if you scan over and over for the same issues, you will find bugs in like 2 weeks maybe, or like, yeah, you just have to be patient, and it pays off basically. Yeah, so like we had great infrastructure, like it was working really well, and we started finding issues, but we started finding too many issues. Like we couldn't handle basically. As I mentioned before, we were finding like more than 200 security issues weekly, and one thing, like one specific thing with automation is that if you are too slow with reporting security issue, when you report it like too late, you will get duplicated by like other people that automate. So if your automation detected issue, you had to like instantly find time to report it and to like escalate it. And if you didn't do it, like yeah, you will get duplicated. Also, like if you find vulnerability, try to escalate it because yeah, it's great that you can get like really fast some money, but uh, if you try escalating the bugs, and like we did so many times, we like tripled the amount or like doubled the amount, and yeah, like by spending a couple of hours on the vulnerabilities. And also one more thing about the automation was the revenue from the automation was really unpredictable. Like you know how the bug bounty game works. Like some of the companies will pay you, others don't, and or some companies will pay you in. You will have to wait like 6 months for the um, for the money, and yeah, like it sucked because we had to pay the bills every month for the automation. And also, like I have a question. Uh, like, what do you think was our bill for the digital ocean for the whole automation? Because I will create a pool. You can answer the questions. You can like give your guess. What was the amount for like scanning 2 million hosts daily? Yeah. Our approach, like at the beginning, was like when we were finding the issues, we just thought, okay, let's do it by hand, let's write all of the reports. But yeah, we quickly learned that it wasn't the way. Like we had to scale it somehow. So basically, we created like semi-automatic way of reporting. We had like report templates, and yeah, we just changed the endpoint. That, for example, we had template for Swagger UI XSS, and yeah, we just replaced the endpoint, and we send the report to HackerOne or somewhere. Yeah. Yeah, so our key learnings from the whole scanning. Building good infrastructure and maintaining it is really hard. Like it is one person job or like full-time job to do this because things will break in unexpected ways, and you have to like make sure the automation is running all the time. So yeah, like if you want to hack and you don't like touching the infrastructure, like don't automate because it will suck, because like it will be so much work for you to maintain the code for it, and like make sure it is working, the database is not overloaded. Like yeah, there's so many tasks, like different tasks that are not hacking related that you will have to perform. Yeah, it's not great experience. Another thing is you can't report every vulnerability. There's basically not enough time. Like you won't have time for reporting all of the issues. So you have to like prioritize only the best ones and focus on them. And one thing that I mentioned before is don't get discouraged if you don't find issues in company like at given point in time. So if you run your scan like today on some company, and if you don't find anything, like don't get discouraged, because developers constantly change the code. And maybe you didn't find the issue today, but if you constantly scan for the same issues, like eventually you will find something. I don't know when, but yeah, like it happened so many times for us. Like basically you need to wait patiently for the changes like to happen, and yeah, developers make mistakes, and you need to like be first to notice it. And also prioritize only the good bug bounty programs. Like you heard some horror stories probably on Twitter about some bug bounty programs, and yeah, like ditch them. Like do not focus on the bad bug bounty programs. Like it's not worth. Like we learned it the hard way, and after a couple of months, basically we had like a block list of bug bounty programs that we didn't scan because they were awful to us. So or like they weren't paying, or like we had bad communication with them. Also, the numbers are in USD. Sorry, in the monthly billing in the pool. Okay, so I have like thoughts about how you can win the automation war in 2023 and 2024. There's a couple of ways that you can differentiate yourself from others, because like there is so many tutorials how to create your own automation, and it is really competitive landscape out there. Like there's so many people scanning right now, and you have to find a way or find ways how to be better than them, or like how to what to do different. So one of the things is is just be consistent. Like scan for simple misconfigurations, like every couple of hours. Do it consistently, and don't get blocked by web application firewalls. There's like so many vulnerabilities that, for example, subdomain takeovers, or debug mode in Django, like different things that are stupid simple misconfigurations that happen quite often, or like maybe not quite often, but relatively often. And if you watch for this misconfiguration, you will find them. So be consistent be more consistent than others is one of the things that you can do to differentiate, to find better results than others. Another thing is you can find new or unknown misconfigurations. If you use the same template as everybody else, good luck, you won't find anything. You can create variations of those templates, like we did, we created our own custom modules to create misconfigurations that weren't found by other people. Basically, spend some time and try, playing around with those templates, adding your own twist on them, because it will make you money. Another thing is you can look for new CVs, because there are different approaches to automations. You can also look for CVs, because we tried this approach as well. You can look for or watch for every new CVE and try creating a proof of concept. You have to be the first to do it before everyone else, and then you will succeed. We did it with Log4Shell, and we earned a lot of money on that. I think $40,000. So also, last thing is just try finding more bug bounty programs than others. You can focus only on private bug bounty programs, because you will have less chance because everybody is scanning public bug bounty programs. If you scan private programs, there is less chance that there will be competition there for scanning. So you can create accounts on so many bug bounty programs and wait for the private invites. And then scan only those. This may work as well. And that's it from my presentation, and I will answer some of your questions. If you want, you can reach me on my email or on Twitter. And I also added to the resources link to our article, how that is more in depth about or not more in depth, but that touches some of the issues or some of the things that I told you about today. So I will answer some of the questions. How do you deal with the CDN IPs wired for scanning? This is the answer from Alexander. Yeah. I do not think I understand. Like, but we scanned like every IP. Like, we didn't differentiate the IP like between CDN or like anything else. Yeah, like it wasn't efficient. We know that. But yeah, like we scanned everything, so we didn't differentiate. Another question. How did you implement IP rotation on every request? Have you used forward proxy or something like that? Yeah, like, so we didn't implement IP rotation on every request. Our IP rotation was on scan basis. So it meant that every scan, like if you had like 3 scans daily, each of the scans had different IPs. So yeah, we didn't change the IP between requests, but between scans. So yeah. Next question. Yeah, the automation scene is competitive and time sensitive, and also the infrastructure takes significant investment of time and money. Is it something that can be sustainably done over the long term? It depends. Like from my perspective, it is really hard because yeah, like you will wait months for like some payouts, and you will have to pay bills. So yeah, like it's really hard, and not yeah, it's hard, but you can make it work. And also, yeah, I will answer the pool questions. I asked you, what do you think was our monthly bill for the automation? And like nobody answered correctly. The monthly bill of our infrastructure was $3,000 every month. So yeah, like we had to earn so much money from bug bounty to like cover, like yeah, we basically every month we had to earn at least $3,000 to like be even. So yeah, so yeah, it was hard. Next question. How did you manage database, especially updating the database for new data when I already have so much data? Which kind of database did you use? We used Cassandra database, and we host it ourselves on Kubernetes. Like it wasn't great experience. We had to learn a lot, like about managing databases, but yeah, we did it ourselves. Next question. Some program ask custom header to be included in every request made. How to approach these programs? Yeah, to be honest, we didn't include it. Like we had the IP rotation, so like we didn't had time to add it, or like yeah. So we didn't include it. Like we were yeah. This was like one bad thing that we did. Like yeah, basically we didn't have this feature. Next question. Oh, I think you are yeah out of time.
Hey, David.
Yeah.
I mean, no,
Hello.
I think we
Yeah.
are. It was a wonderful presentation, David.
Yeah. Thank you.
Thank you so much. And yeah, we do have time, but I think you have answered almost most of the questions that people had posted. There's one more question. Just
Yeah.
bring them on stage.
Okay. Are there any red flags or rules of thumb you identify good bug bounty program for bad one? Basically, we have to report at least one vulnerability to program to like see how they react and how they answer. So yeah, like we learned it over a couple of months, like which programs were good and which programs were bad. So yeah, yeah, and also some of the programs are private programs, so I can't give you like an answer like which programs are bad. Yeah.
Yeah, that's just to add to what David had mentioned. I use like a rule of thumb. I check the time in which they resolve bugs. Not even resolve. If they like make a comment to the report or anything, if they're quick, then probably it's a better program. And then the if there's like a sliding bounty as well, I think it's a pretty decent one to approach.
Oh yeah.
Yeah,
That's great rule of thumb. Yeah.
Yeah. So let me check if we have any other questions. I think we do. Yeah, I think you had answered almost all the questions, David.
Yeah.
And yeah, I think that brings us to the end of the session. And once again, thank you so much, everybody, for joining in. And thank you so much, David, for this wonderful presentation.